Let's get some attendance checked in here, and we'll start with some questions. I'm guessing that we probably have some questions from the review or other things. I went by and looked at your guys's the homeworks and whatnot here, so it looked like there's probably going to be some questions, which is fantastic. Not a problem at all. Let's see. So take a minute, kind of look over your things to see if you can find anything. All right. So questions from anything, I guess. Josh. So we're talking about the review, this one right here. Okay. So this problem, this one right here. Okay. What do we ask to do? Are these functions or not? And then show you. Okay, so what we have is a graph, right? Now this graph is 3 distinct segments, or 3 disconnected segments, but that's okay. Still just a graph. My main tool to determine whether it's a function or not still would just be the vertical line test. So no matter where I draw my vertical line, there's no spot where I'm going to intersect that graph more than once. So I would say this is a function, and I would just say that it passes the vertical line test. Is that okay, Josh? Okay. Others? Yes. Sure. Okay. So we're talking about this one right here, right? Okay. So identify any discontinuities in the function and determine the type of discontinuity. So one way you could attack this right from the jump is to look at the graph. So let's do that as just a starting point, and we'll talk about algebraically what you could do after that. But this is a pretty good starting point to just start by looking at the graph. So I'll take out my calculator. I'll turn it on and I'll go to the y equals. And anything that's in there, I'm just going to clear out. So I had some stuff from a previous class. And what I'm going to do is I'm going to type that guy in there exactly as it looks. So I'm going to use a couple of little tricks here. To get the fraction, I'm going to do alpha y equals. That opens up the fraction menu. And the one that we'll want probably more often than not is that first option, numerator over denominator. And then I need to get that absolute value symbol. I get that from the math menu. And then over to the numbers tab. And then ABS is short for absolute value. And then I can do 2x minus 1. And then negative 2x plus 4. And we can hit graph. So if I look at this, I see one discontinuity. It's right here. You agree with that? That type of discontinuity is an infinite discontinuity. That looked like at x equals 2. Alternatively, if I was going to do this algebraically, I would notice that this is a rational function, which has a vertical asymptote where the denominator is equal to 0. That vertical asymptote is a type of infinite discontinuity. So I could just say, okay, I'll just take the denominator and set it equal to 0. And that'll give me x equals 2 also. Okay, so just from a picture standpoint, can we do it that way? Okay, so in infinite discontinuity, is something that kind of looks like an asymptote, which that discontinuity, the graph shoots off to either positive or negative infinity. A removable discontinuity it's just like a graph where there's like a little hole in it. So something like this. So from an equation standpoint, an infinite discontinuity might look like this. A removable discontinuity is something that you could factor down to be like this, where you have one piece kind of crossing all the way out. Does that help, Isabella?
Yeah. Did you also do
Yeah, are there follow-ups on C before I move on? Josh, you had your hand up. Is that follow-up on C or you have something else? Okay, let me get this other one from Isabella and we'll come back to you, okay? Okay. B then. Okay. So here, let's just do this algebraically to start, and then we'll do it graphically just for a change of pace to show it doesn't really matter. Again, this is a rational function. So I'm going to start by factoring, because I noticed that unlike the previous one that just had a linear over linear, here I have quadratic over quadratic. So there's possible some reducing that could happen that couldn't happen if I have linear over linear like that. Okay with that? So I notice in the numerator I can take out a greatest common factor of x. And in the denominator, I can also take out a greatest common factor of x. So I could reduce those down to get this. Okay with that? When I reduce that out of there, that's giving me my removable discontinuity. In this case, I'm going to set the piece that I crossed out equal to 0, which is already solved for me. There's nothing really to do because it's just x. This piece is a rational function, so it has a vertical asymptote. It has an infinite, so I'll just set that denominator equal to 0 to find it. So I should have two discontinuity here. I should have the removable one at x equals 0 and an infinite one at x equals -3. Does that feel okay, Isabella? Now, if I go to try to look at this on my graphing calculator, that's going to be tough to see the removable one. And what makes the removable one, or what's going to make the removable one so hard to see visually, is that it's happening at the origin, because there's the XY axis that's printed on my calculator is going to kind of look like it's filling in the gap there that's going to be created. But let's just type this in real quick and I'll show you what I mean. And there is a way to kind of to check that still. But let's do this real quick. So there's my vertical asymptote at x equals -3, right? That's easy to see still. And now, technically speaking, there should be some hole here at x equals 0. But if there is, the xy axis is kind of getting in our way. Even if I could see the hole, which might be hard at the current window, I couldn't, the gap that was there was probably going to be filled, the pixel would be filled in by the xy axis. So we can do this. I'm going to press second and zoom, and I'm going to turn off the axes. So if I hit graph again, it's going to graph this with no xy axis present. And if you look very, very carefully, there is a little piece missing here, although that's probably pretty hard to see right now. So let's take a closer look. So I'm going to resize the window just around this area. So since I care just about what's happening near 0, I'm just going to do -0.5 to +0.5 on the x, and maybe -1 to +1 on the y, and just get this little tiny window of that graph. And boy, it's still hard to see there that there's a little piece missing, but it's a little bit easier to see. Let's just try a general zoom in. So I just press the zoom button and pick the zoom in command. I want to center right on that spot that it's missing. If I do this a bunch of times, I might get a decent gap in there. But since it's always just a single point, it's definitely hard to see, right? Even now, after I've zoomed in a bunch of times, the people in the back are probably looking and going, I don't see a little gap there. I promise you I can see it on my screen, but I'm a heck of a lot closer than you guys are. And it is definitely hard to see. It is one of the bonuses about attacking these algebraically is that it's much easier to find those removables than it is just looking at the calculator. The good news is, though, if the degree of the numerator and denominator are both 1 or less, I don't have to worry about a removable discontinuity. It can't happen. So like on a problem like C, I didn't have to worry about it. I knew that there could be no removable discontinuity because I have a degree 1 over a degree 1. Now, technically speaking, there could be a removable in part A, but if I look at the type of factoring going on, it's easy to see that there wouldn't be, right? Because this is going to factor into two binomials, and this is just a monomial, so I couldn't reduce anything there. Now, there technically could be something here in D, and I think indeed there will be a removable discontinuity in D, as well as two vertical asymptotes or infinite discontinuity. Isabella, does that help? Okay. Yeah, I'm glad to do it. You're welcome. Josh, what are we doing? Where are we going next? Okay. 2C. So this one right here. Yes? Okay. So we want the domain of the function given in interval notation. So if I look at this function, there's two places, or two things that could make my function undefined. The first part is I could have a negative inside the square root. And the second is I could have a 0 in my denominator. So I'll just take those separately. So I know this piece has to be greater than or equal to 0. This cannot equal 0. So far, so good? Okay. And then subtract 5. So I know x has to be greater than or equal to negative 5. And here I'll factor this. And that should, when I set each of those factors not equal to 0, I get that x cannot equal negative 1 and x cannot equal negative 6. Okay with that? Okay. Now I just have to combine these two things together and get an interval out of this. And that's maybe easier said than done. So this is the way I would look at it. So I'm going to draw a number line. And I'm going to just draw in these three things separately. So greater than or equal to negative 5 looks like this. Cool? X not equal to 6 looks like this. And then x not equal to negative looks like this. Josh, are you okay with what I did there? Okay. Delaney? No. So the range we're not doing here, and I wouldn't ask you to do a range on something that's difficult. So the domain we have to worry about is when the function is undefined. So the numerator has a square root in it, so I have to worry about negatives in the square root. So I know the numerator has to be greater than or equal, or the part underneath the square root, really. I should just have done that. Correct. The numerator has no effect on f, other than the possible reducing that can happen, but we don't have to worry about the reducing if we're looking for the domain. Don't reduce. Okay, so back onto C here, because we still need to turn this into an interval now, right? So to do that, what I'm going to do is I'm going to take the overlapping parts. So I have one part that overlaps here. All three of those overlap in that section. And then all three of them overlap in that section. Are you okay with that, Josh? Okay. So that first overlap goes negative 5 with a bracket, because all of these have negative 5 in them, all the way to negative 1 with a parenthesis. And then I'll do my union. And the next section starts at negative 1, but since it's an open circle on the green, it's not, negative 1 isn't in all of them, so it gets a parenthesis. And it goes all the way to positive infinity, because it has the arrows at the end of all of them. You can, and you can find that effective. You don't need to do that, but I think it helps visualize what's going on and why, like, the negative 6 didn't matter. You know what I mean? Because at first glance, you'd be like, why didn't you care about the negative 6? So this, I think, is just effective in kind of sorting out when there's a lot of stuff going on. Does that feel okay? Delaney? So if what we care about for the domain is where all three of these overlap, nothing before negative 5 is going to matter, because on the red part, it starts at negative 5, right? There's no red that overlaps with negative 6 anyways. Does that make sense? So if I picked, say, negative 5.5, already the numerator is going to be undefined, right? Anything I pick that's less than 5 is going to make the numerator undefined. So the fact that I can't have -6 was the numerator, so it didn't really matter, is another way of thinking about it. Is that, yeah or no? Are you sure? You're not convincing when you say that. It's okay? Okay. Happy to do some more if you want to do some more. Do which one? E? Okay. Okay. Can I erase some of this stuff? Actually, I can probably just work around it. I'll just do it over here or something. Okay. So does it matter that the two things are added together? No. No. This function will still be undefined when the stuff under the square root is negative, or when the denominator is equal to 0. Does it matter that the two parts are being added together like that? Not a bit. Because undefined plus anything is still undefined, right? So just like before, I'm going to take the stuff underneath the square root and set it greater than or equal to 0. And so I skipped some algebra on the solving. Is everybody okay with me skipping some of that solving algebra? I did some factoring. I set things not equal to 0 and added things to both sides and yada, 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 right? You guys should say that's all easy factoring, right? Okay. So again, I have, oops, I don't know why I put an equal sign there. Should be greater than or equal to. I would do the same number line trick that I just did before to kind of visualize what's going on here. So I have greater than or equal to 1/2. I have not equal to 1, and then I have not equal to -1. And now I'm going to worry about the overlap. I have one overlapping section here that
Isn't that
2. Yeah, I just did that wrong. Thanks. Glad you stopped me before I got too much further. There we go. So here, if we look for the overlap, just that. No, because they're already less than the 2 that I need to have. So it's just going to be literally x is greater than or equal to 2. Or, oops, set interval, 2 to positive infinity. Does that feel okay there? And the number line, I think, helps visually to sort out like what stuff matters or what doesn't matter and how to come up with these intervals, because it's not just by looking at it always obvious, right? Amanda.
do you only do the greater than or equal thing when there's a square root?
Yes. Or well, any even root, like a 4th root or a 6th root or whatever, but yes.
Okay. How do you know what?
So okay. So let's make a list of things that can create an undefined function that we know about to this point in our mathematics. Okay? So we have negative root or any even root. We can have 0 in the denominator. There's one other thing that you guys would have seen last year that can make something go undefined. What other function did you use last year that had a vertical asymptote in it? Logarithms. If you take a logarithm of a non-negative, that also gives you undefined. So 0 and less. Note that non-negative is different than, I should say, I'm sorry, logarithm of non-positive. Excuse me. Non-positive and negative are different. What are they different? Or what do they differ by? So I chose those two terms carefully. What's the difference between non-negative, I'm sorry, between negative and non-positive? Those two terms mean something different. Yes. Yes. Very good. So you should hopefully remember that log of 0 is also undefined, in addition to anything negative. So those are the only three things that you guys know about to this point that can make an undefined function. So if you're looking for stuff to figure out a domain, those are the only three situations you have to worry about. Now, we didn't see any of these to this point, right? You think you'd see one on the test? So really, the only two situations you need to worry about are x's in the denominator and x's under square roots. Right? Because we haven't even seen even roots other than square roots, right? Does that feel okay? Did that help? Yeah. Okay. All right. Other questions. These are good ones, guys. You can keep them coming. Jacob.
You do 1.8.
1.8 part B. Yeah, I sure hope I can. Oh. Okay. All right. So let's see. Horizontal stretch by factor of 3, reflect across the y-axis, and translate down 4 units. Okay. So the first thing I would want to do is figure out the values for what this means in terms of A, B, H, and K. So we have a horizontal stretch and a reflect across the y and a translate down. So none of those are going to involve H. So H is just going to be 0. And none of those are going to involve A. So A is just going to be 1. Right? A is vertical and reflecting across the X. So are you okay there? Okay. So the reflect across the y tells me that B has to be negative, and the horizontal stretch by factor of 3 tells me the magnitude of B should be 3, so B is negative 3. Okay with that? And the translate down 4 units tells me that the down part tells me K is negative, and the 4 units tells me it's negative 4. Good with that? So now I'm going to use that general transformation that G A times F of 1 over B times X minus H plus K, and fill in the values for A, B, H, and K into this. You okay with that? Okay. We don't do that. So that just becomes this. Okay? So now I know what f of x is, right? Tells me in the problem. So now let's evaluate this. So I'm going to have f of negative 1/3 x becomes negative 1/3 squared plus 3 times negative 1/3 x. And then I still have that minus 4 that I have to tack on to the end. Okay, there. And then I just simplify. So negative 1/3 squared is 1/9, and x squared is just x squared. 3 times negative 1/3 x just becomes negative x. And then I have minus 4.
Wait, why do you do that?
Why do I have to do, okay.
Yeah, doesn't it always change into that?
I just, what do you mean?
Never mind, I looked it up.
Okay, I'm sorry. You mumbled something and it was kind of fast and I just wasn't paying attention and I missed it all. It was probably a really well thought out, coherent question. I was just not paying enough attention to catch it. So that 3 is from here. So when I do f of negative 1/3, I'm just plugging negative 1/3 x into both locations, right? Just like when we do composition. So this 3 here is that 3 there. This squared here is that squared there. And the negative 1/3 x is what we're plugging in to our function. Because b is negative 3, so that's negative 1/3, and h is 0. So x minus 0 is just x, and negative 1/3 times x is just negative 1/3 x. So I have my function f here is this function. So if I do f of 2, you're saying that I would just do this and plug the 2 into just one place? No, it plugs in for all the x's, right? So the only difference is in our case, instead of plugging 2 into everywhere, we're plugging negative 1/3 x into everywhere. Did that do it? Okay. Again, if I'm not explaining something, keep pushing at it and I'll go and try to explain it a different way, and that's okay. It's important that you understand. All questions are valuable questions.
You do A too.
Sure. Okay. So reflect across the x. What does this mean? It means that a is negative, right? Translate 3 units to the right. That tells me h is 3. Everybody okay there? So the question becomes, okay, a is negative, but what value should it have? Well, is there any vertical stretch or shrink going on? That part tells me that the magnitude of a has to be 1. So a needs to really just be negative 1. So my function g of x then will be negative 1 times f of 1 over 1 x minus 3 plus 0. Right? Notice there's nothing else here about reflecting across the y-axis or horizontal stretches or shrinks, so b is just going to be 1. And there's no shifting up or down, so k has to be 0. So now I just need to evaluate this. So I have negative 1 still out front. And f of x minus 3 is going to be x minus 3 squared plus 3 times x minus 3. Sophie, are you okay with what I've done so far?
No.
Okay. So now I have to FOIL out the x minus 3 squared. And I have 3. And then when I combine like terms, I get this. And when I distribute the negative, I get that. So that's like my final answer. Does that feel okay there?
Mm-hmm.
What else should we talk about? Happy to do more. Again, allocated this time for questions on really anything. You could talk about the homework too. If you want to talk about the homework, that's okay. Or the review. Either is fine. Whatever you guys need to talk about today, we can talk about. And we'll go till you guys are out of questions. That's fine. So you can ask as much as you want. It can be hyper specific or kind of general. It doesn't matter. Amanda? Sure. Problems 56. Okay, so it says to verify that the two functions are inverses. That's fine. So to do that, we need to show two things. We need to show that G compose f of x is equal to x, and then and then the reverse. Okay with that? So those are the two things that I'm going to do. So for the first one, I know that f compose G is the same thing as f of G of x. Okay with that? That's just the definition of composition of two functions. And now I'm going to just replace G of x with the expression that it's equal to. So that's natural log of x plus 5 over 3 minus 1. Okay with that? And now I'm going to plug this into f of x. So I have 3e to the natural log of x plus 5 over 3 minus 1. And then I have the plus 1. And then I have the minus 5. Amanda, are you okay to there? Okay. So the first thing I would do is I observe that like this set of parentheses here doesn't really need to be there. So if I drop those parentheses, I can cancel the minus 1 and plus 1. And then I remember from my Algebra 3-4 class last year that exponentials and logarithms are inverses of each other. They cancel each other out. So the natural log is the same thing as log base e. And if I have log base e to the e to the log base e, they're going to cancel each other out. So what I'm left with is just 3 times. And then the times 3 and divides by 3 cancel each other out. And those parentheses don't really need to be there. So the plus 5 and minus 5 can cancel each other out and left with just x is equal to x, which is what we wanted to show. Now we just have to do the same thing going the opposite direction. So this is g of f of x. Oops, do that. And then we plug in our value for f of x, 3e to the x plus 1 minus 5. And I'm going to plug that into g. So I'm going to have the natural log of 3e to the x plus 1 minus 5 plus 5, 3 minus 1. So first thing I notice is that these parentheses don't really need to be there. So the plus 5 and minus 5 cancel each other out. And then I notice the times 3 and the divides by 3 cancel each other out. And then I remember from my Algebra 3-4 class that natural logs and exponentials base e cancel each other out. Hi, Miss Anderson.
Hello.
How are you?
For you.
Oh.
I had to change him to from fourth to fifth or fifth to fourth or something like that.
Oh, okay.
And so I printed this for you so that you wouldn't lose that data.
Okay. Thank you.
You're welcome.
And then here, obviously the parentheses, again, don't need to be there. And those guys will just cancel out. And we're left with just what we wanted. Okay with that, Amanda? Yeah. So again, like, worst part about this is remembering your log and exponential stuff from last year, which, again, you guys did, and you knew how to do at one point, whether you remembered how to do it when you got to the homework. That's a horse of a different color, but hopefully with a little bit of kind of refresher and going through and doing some of this stuff like we're doing right now, that memory jogs itself a little bit. Now this was a pretty complicated set of compositions to do because there's a lot of stuff going on to cancel. But if you can do this, you're in excellent shape. Like, this was hard. Don't get me wrong. There's a lot of algebra going on there and a lot of stuff to kind of keep track of. Easy to make mistakes on and try to do stuff out of order or whatever. But if you got this, then you're going to be in nice shape, in good shape for this kind of problem. Who else has some? Isabella. No, you don't have to apologize for asking questions. Don't say I'm sorry. It's okay. Again, you don't have to make excuses or make any, just you have questions. That's fine. That's what this time is for.
Can we do B for
one? Okay, let's see. Do I have 1.7 on here already or no? I do not. Okay. So let me go back and grab that. This one. Daisy, what did I just do here? Okay. And you wanted to do which one again now? B. Okay. So this is the multiplication of two, which we remember we defined as just g of x times f of x. So that's going to give me the square root of x minus 1, which is just this. Okay? So now we need to worry about the domain. So, because I know that undefined times undefined will still give me undefined. If either of these two functions are undefined, it's going to be a problem for me. But I can really just look at this one, since that's still the same thing, right? So if I take the square root and set the stuff under the square root, it has to be non-negative. And the stuff in the denominator can't equal 0. I have something like this, and if I do my number line thing, I have greater than or equal to 0, and then not equal to 1. So it's going to give me 2 segments, 2 overlapping pieces. So I'm going to have 0 to 1, with a bracket on the 0 and a parenthesis on the 1, and then 1 to positive infinity. Mm-hmm. Yeah. How about just g of x equals the square root of negative x? If I do that, when I get to here, I'd have negative x is greater than or equal to 0, which would just turn into x is less than or equal to 0. So this would be going the other direction. So you'd be going negative infinity up to 0. Oops. Is that okay? So again, like, not hard to get one with a negative infinity on it, but it probably just means that the square root you had to divide by a negative underneath your square root or whatever. Okay. These are good questions. I like the hypothetical ones, like, ooh, could this ever happen? What would it look like if it did happen? Those are good ones. Caroline. 1.5C? Uh-huh. I don't think we have that one up there yet, right? You guys have probably been paying more attention than I have about what's going here. That. I want to do something over here real quick. .5 number. So you want this one, right? Okay. I just always double check because the ABs sometimes we get thrown off. Okay. So my 2 tools that I'm going to use, I know that odd, if this rule is true, then it's odd. And then for evens, if this is true, it's even. In either case, we need to look at f of negative x. So that's what I'm going to start with. So h of negative x. Okay, there. Negative x to the third power is still negative x. Negative x squared is positive, but then I have a minus sign in front of it, so it's really like 3 negatives. And then I have the plus 2. So this is not equal to f of x. So I know it's not even. Let's see if I factor a negative sign out. Is not equal to f of x. So I also know it's not odd. So I would write neither. Is that okay, Caroline? Yep. Do you remember the quick check to help you tell if the polynomial one is going to be even or odd? So if you look at if it's a polynomial, each term individually, the first term is degree 3, the second term is degree 2, the third term is degree 0. If the degrees are not all odd or even, then it's got to be, if all the degrees are the same, then the function will be that degree, or will also be that odd or even. And if they don't all agree, then it'll be neither. Yes, you have a degree 4, a degree 2, and a degree 0. Those are all even degrees, so that's an even. Yes. Now that doesn't work as a proof, but if it should tell you whether you've done your proof correctly or not, right? Giving you the right result. That's only true for polynomials. Keep in mind. So the rational ones you have to be a little bit more careful with. Josh, you had your hand up earlier. Can I answer another one, a question for you? Oh, okay. Sophia.
For like numbers, like section 1.8a through like d, we have to write like 1 and then like if there's nothing that goes with it, a line through it, or can we just write the things that actually like...
Hold on, let me... So we don't have that page, right? Let me get it real quick. We want... Oh, no, we do have this page. Oh, it's because I didn't do this last half of it, right? I looked this page, but I guess I just got excited about the other thing. Oh, we didn't do that at all. Okay. So you're asking a very specific, like, what do I really care about kind of question,
yeah,
right?
Like, do I have to write all 1 through 6, or can I just like write what it's actually?
You should write all 1 through 6 and write.
Okay.
And if it's blank, you can just leave it blank.
Okay.
But like write the 1 through 6 and try to keep them in the right order because we do care about the order.
Okay.
Is that?
Yeah, it does.
Okay. Sorry, I don't know why I need to see the question to answer that, but it's immediately like I need to look at the question before I can answer anything. Just the way I am. It's the math teacher in me, like, let's be hyper specific. I don't want to answer something too generally and be like, uh-oh, when I told you this was always true, I forgot about this situation, which it doesn't work, so it's not all, like. Yeah, who's next?
I got it.
Of course, go ahead.
Wait, okay, what is like, or like when you're doing C, what's it, negative hx compared to like h negative x? Like I was trying to figure that out looking at like the B and D because those are
Okay.
odd.
Okay, I'm sorry. Can you tell me the number?
So, sorry. At 1.5.
1.5. Okay. That's okay. Again, like, we've been jumping around. If I'm not sure, I'm going to just stop you. Okay. So 1.5, you want to talk about which one?
Like, I know A and D are, like, odd because of, like, the rule you're telling us about. But what I don't really understand is, like, what...
I'm not sure that's true. I mean, the rule that I was telling you about definitely doesn't apply to B or D because they're not polynomials.
Well, wasn't that, like... Oh, but that only, it doesn't apply to that.
No.
Okay. Okay, I'm just confused on what, like, negative hx means.
Okay. So let's say f of x is equal to x plus 1.
Yeah.
Okay. So negative f of x would be negative 1 times x plus 1, or negative x minus 1.
Oh.
Okay. F of negative x would be plugging negative x in, which would be negative x plus 1. Okay? That's kind of what you're asking?
Yeah.
Should we do B or D?
Yeah.
Okay. Which one would you prefer? I'll happily do either. Okay. So we'll start by doing g of negative x. So I'm going to go ahead and plug negative x in for everywhere I see an x. And then we'll simplify this down. So this is not g of x, because there's a negative sign in the numerator, right? So we know it's not even. Now I can factor a negative 1 out. Well, let's be a little bit later. But I can't take anything out of the denominator other than a positive, right? I can think of that really as just negative 1 over 1 times that, right? And that's really just the same thing as this. You agree? Which is negative g of x. So it is odd. Although you could not have told, because if you look, this is odd on top, this is even on the bottom. Odd over even apparently is odd. Is that always going to be true? I think it will be.
Wait. Yeah.
Yeah, I think so. Odd over odd, or odd over even, or even over odd should be odd. Even over even should be even. And then odd over odd should be even. Right? Do we think that's always true? Odd over even, or even over odd should be odd. And then even over even, odd over odd, those should both be even. And then if there's a neither involved, I'm not sure. Why would this be true? Can we prove something like that? We should be able to prove that, right? So let's say that our f of x is some g of x over h of x. Then I know that if we do f of negative x, that's going to be g of h of negative x. Since g of x is odd, I can do that. And since h of x is even, we can say that, which is the same thing as, right? Which is negative f of x. Right? So we can say that that's always true. Maybe the more surprising one is that odd over odd is even. Why would that be true? Well, in the case that both are odd, this happens, and then the negatives cancel out, and then we're left with f of x, which is what we'd expect for an even function. I think if either one of them is neither, it's going to make the whole thing neither. But I'd have to really kind of think about that one. Amanda.
Okay, mine goes off of the question that we just did.
Okay. So you say our function is negative x over negative x squared minus 1?
Like, if that would have been the answer.
No. Oh.
Like, instead of negative x
Okay.
over x squared
Sure.
plus 1.
So if I did that, I can factor negative 1 out of the numerator and factor in negative 1 out of the denominator, right? Those are cancel out. And I'm left with h of x exactly.
So what is it?
So this is a what if. Okay. Good questions. This was the same thing that we observed was happening down here when we're trying to prove odd over odd gives us even. That's the same canceling of negative signs we just did on that previous one, right? These are good questions, guys. I like where your heads are at. Very what ify. I like the what ifs. Shows me you're thinking hard about like all the different possibilities of things, how things can happen. That's hard to do, right? Like trying to sift through all the possible outcomes and try to decide if something always happens this way or can it happen a different way. That's good. That's real mathematics there, when you're trying to find the governing dynamic or like the overlying principle. What else do you guys have? Okay. Do you want to talk about test format or something? That's probably worth talking about, right? Yeah? Okay, let me do this real quick. Oh my goodness gracious. Okay, do that.